All right, this example is asking us state each state each in terms of the same trig function and the reference angle. So we've done these before just in terms of sines and cosines. So now this is asking us to find the state the secant of 310 degrees, but do it with a reference angle. So that's where we have to adjust the positive negative sign of this function. So before I get into this, I just kind of want to go over this. So right now we've been working with the three main trig functions, sine, cosine, and occasionally tangent. So I just want to point out that all of the trig functions, sine, cosine, or tangent, if the angle terminates in the first quadrant, then the sine, cosine, and tangent values of that angle are always positive in the first quadrant. That's kind of what I'm showing you right here. This is quadrant 1, and basically I'm saying all the trig functions are positive in the first quadrant. And that also goes for the reciprocal. So we have sine, cosine, and tangent here, but then we also have secant, cosecant, secant, and cotangent. Now, once we get into quadrant 2, the sine function is the only function, the only main function that is positive when the angle terminates in the second quadrant there. Cosecant is its reciprocal, so now that means that sine and cosecant are positive in the second quadrant. Tangent is the only, so tangent is the only function that's positive in the third quadrant. And because cotangent is the reciprocal, that also means that now tangent and cotangent of any angle that terminates in the third quadrant is going to produce a positive value. And then lastly, cosine is the only positive function in the fourth quadrant. Now that we know that secant is its reciprocal, then we can say that cosine and secant are the only two trig functions that are positive down there in the fourth quadrant. Again, don't forget, all of the functions, sine, cosine, tangent, secant, cosecant, cotangent, they all produce positive values for angles that terminate in the first quadrant. The mnemonic that many kids use is all students take calc. It's just a quick way they remember it based on the main trig functions there, and then they just also know that they know that the reciprocal functions, they know what the reciprocal functions are for each of the main ones. So in this case, secant of 310, first thing I would like to do is maybe give myself a visual. So I'm going to measure 310 degrees. It's going to go all the way around and terminate in the fourth quadrant. So let's just say it's right there. So this is 310. And then I need to find my reference angle, right? So here's my reference angle. So a quick way to do that would be 360 minus 310 degrees is going to give me a 50-degree reference angle. So this is a 50-degree reference angle. I am in the fourth quadrant, right? So if I'm looking at a triangle, I have a negative vertical length on my triangle, and I have a positive horizontal length on my triangle. So basically, I would be taking the secant of 50 degrees. So I'm going to write that down right now. Right? Secant of 50 degrees. And then what I need to do is make sure I need to make sure I do or do not need to adjust the positive negative sign of this. Right? So if you go back over here, cosine and secant are positive for all angles that terminate in the fourth quadrant, which is exactly what is happening with this angle right here. It terminates in the fourth quadrant. So I have my reference angle of 50, the secant of a 50-degree angle, which is going to terminate in the first quadrant, is also positive, which basically just means that I don't need to change the sign. So secant of 50 is going to produce the same value as the secant of 310 degrees there. Cosecant, on the other hand, let's take a look at that one. Move this out of the way slightly. Give myself a circle first. 200 degrees terminates just about there, right? That's my 200-degree angle. I'm going to give myself a little triangle here. So I have both the legs on my right triangle now are going to be negative because I'm down here in the third quadrant. Going back to my little chart here, the tangent function and the cotangent function are the only functions that produce positive values for angles that terminate here in the third quadrant. And I'm dealing with cosecant right now. So that means that the sine and the cosecant are going to be negative in the third quadrant here. So that I'm going to have to adjust my positive negative sign. So first is the reference angle. I have 200-degree original angle. So my reference angle is going to be measured right there. So that's going to be 200 minus 180 degrees. That's giving me a 20-degree angle. So then I'll turn around and say cosecant of 20 degrees is the reference angle. And then what I need to do is I need to adjust the positive negative sign because the cosecant of 20 degrees is going to produce a positive value up here in the first quadrant. That's where 20 degrees terminates. But I am really down here in the third quadrant, and cosecant is negative in the third quadrant, so I have to adjust my value here and put a negative there. Parts C and D are very similar to A and B. The difference is we're dealing with radians at this point, and it's kind of like the same concept there. So I'll do one of them. Get rid of this. So tangent of 2 radians. Sometimes you need to kind of get a sense of where 2 radians exist on your unit circle. You might have to do that by, if you remember that pi is 3.14, then you can approximate what pi over 2 is, just to kind of give yourself a sense of where 2 radians is. 2 radians is going to terminate in the second quadrant. Again, this is just an arbitrary angle, but that's 2 radians right now. So if I go and create my triangle, I have a positive vertical, but I have a negative horizontal here. And then if you go through your chart, I'll write it up here. All functions are positive in the first, sine is positive in the second quadrant, tangent is positive in the third, and then cosine is positive in the fourth. The reciprocal functions are also positive in the corresponding locations as well. So my reference angle is right here. And that's the first thing I need to do. So remember, a full half a rotation is pi radians. So I would take pi radians and I would subtract the 2 radians I have, and this is my reference angle there. So I would set this up and say the tangent here of pi minus 2 radians, that's the reference angle. And then what I need to do is figure out, do I need to adjust the sign, positive or negative? So in the second quadrant here, the angle terminates. Only the sine and cosecant function are positive, which means tangent is a negative value, right? So I need to now adjust this to make it negative, right? Because the tangent of pi minus 2 is pi minus 2 is a first quadrant angle, and the tangent of any first quadrant angle is positive, but the real angle we're working with here is in the second quadrant, and tangent is negative in the second quadrant, so I need to apply a negative sign right up here. And that's pretty much it for this, the other examples on this page. They kind of give yourself a diagram, figure out what quadrant you're located in, find the reference angle, and then adjust your positive and negative signs depending on what quadrant the original angle terminates in, and you're good to go. Don't skip out on this with the assignment. It is pretty critical that you kind of master this stuff.